left hand there.
Prashant? Prashant?
Yes, sir. Yes, sir.
Today's session has been sent a link. The reminder has been sent to delegates.
Yes, sir.
Yes.
We already sent the reminders.
Okay.
Yes.
Am I audible now?
Yes, sir.
Let's see. Okay. We will be starting straight into the session, isn't it? You will introduce the.
Yes.
Introduce the Dr. Ashok, hi. That time there was some problem with my audio. Can you hear me, Dr. Ashok Reddy?
Yeah, we are able to hear
Yeah.
you, sir.
Yeah.
Dr. Harish has yet to join.
But Ashok, noise is there. Your voice is audible, but noise is there.
This is
We are already streaming on YouTube. We are already live. So probably another couple of minutes we can, once the Dr. Harish comes, we can start.
Good evening, Dr. Vidya Kumar. Good evening. Welcome.
Good evening.
I think you are muted, right? Okay. Fine.
Okay.
Fine. Fine.
Yes, sir.
Sir, 3 minutes left to go live.
Welcome, Rajshekhar.
Hello.
Good evening, Dr. Harish, sir.
Good evening. Good evening, sir.
Good evening.
Sorry, a little bit in a hurry. It's okay.
Yeah.
Good evening, Dr. Harish. Good evening. Ashok here. Yeah, hi.
Sir, we are live on YouTube now.
Yeah. So I start. Who my co-chair, Ashok Reddy, sir. Hello. Hello.
Hello.
Yeah. Hello, sir.
Yes.
What
Sir,
is
namaskar.
Namaskar. Namaskar. Yeah. So shall I start with the introduction of topic, or we have to introduce topic and speakers? No.
Yes, yes. Probably you can introduce the topic. I'll introduce the speaker, and then we can proceed.
Okay, right. Okay. So very good evening, all of you. Respected President.
Dr. Harish, Dr.
Yeah.
Harish, 1 second. Dr. Indu is coordinating. She will just.
Oh, she will. Okay, yeah, that's fine.
Introduce the chairpersons and then you can start, sir.
Okay, right. That's fine. Yeah.
A very good evening to one and all. A warm welcome to the second day of the Research Capacity Building Lecture Series organized by the Indian Psychiatric Society South Zonal Branch. At the outset, let me request all the participants, the postgraduate students and consultant psychiatrists, to post their questions in the chat box right at the beginning. Whenever they have a question, please post it so that immediately on concluding the session, we can go for the question and answer session. If you wait till the end, there'll be a delay. So please post your questions right at the moment when you have that in the chat box so that they can be addressed at the earliest. So we have had two interesting talks yesterday. Today we are going into hardcore statistics. The first talk is on sampling and sample size calculation. The speaker is Dr. Vithu Kumar K, Additional Professor of Psychiatry, Government Medical College, Ernakulam, Kerala. This session is to be chaired by Dr. Harish M. Tharail and Dr. Ashok Reddy. Dr. Harish is the Professor of Psychiatry at Government Medical College, Kozhikode. He is also the immediate past president of IPS Kerala chapter. He is a researcher himself and the nodal officer of the Institutional Research Board of our institution. I welcome you, sir. And Dr. Ashok Reddy is a professor and head of the Department of Psychiatry at SVS Medical College, Mehboob Nagar. He was Professor of Psychiatry at Osmania Medical College, Hyderabad. And he has conducted various seminars, workshops, CMEs, conferences. Areas of interest are community mental health awareness, use of IT in psychiatry. A warm welcome to you too, sir. Over to the chairpersons to introduce the speaker and the topic.
So, very warm welcome from all of you, all of us here. Respected President of Indian Psychiatric Society South Zone, Dr. Kishan, Secretary Dr. Abhay, and other office bearers, and my co-chairperson, Dr. Ashoka Reddy Garu. So, we are here to, in a very important event of IPS South Zone. IPS is, South Zone is one of the branches that started this program of training, PGCME itself, and also the training program for PGs as a separate activity. So today we have a good topic and a good speaker. Topic is sample size and sample size calculation, and sampling and sample size calculation. Okay, and speaker is Dr. Vidhu Kumar. So Dr. Ashok Reddy will be introducing him, and I will briefly tell something about the topic as an introduction and pass it on to Dr. Ashok Reddy. So you talk about sample size and sampling. Actually, what are we addressing? We are addressing two basic issues that can happen in every research. The first one is bias. Bias is anything that inadvertently that is affecting the measurements and the total study that we are doing. It will affect the way you see the patients, or you collect the data, and even in so at several stages the bias can come in. So to address the bias, we need to have something called a sampling method, how to collect the sample. So that is the first part of it, the sampling, why we need a sampling method to address bias in our samples. The next thing is the power of the study. That is, if we have a lesser sample size, the study is likely to be underpowered. That means even if there is a real difference, we may not detect it. Okay, so we have two concepts of alpha and beta error, the type 1 and type 2 error, based on which the power of a study is, we can the power of study, and it is a variable, an important concept in research. So, and it's a very, very vital topic as far as the research methodology is concerned. Everyone who is starting on a career in research should understand these two basic things, because otherwise, whatever data you collect and whatever sampling, if you take, see, you can do a study collecting, I want some sample, I go to all the 100 in kilometer from my house and collect a. See, that is one way of collecting the sample. You can call it convenience or whatever. So the problem is, could be biases which creep in without our knowing. Even we may not be planning. We want to get a very good sample. It's not a question of our intention is, but there are factors operating beyond the control of the researcher, and that is how bias creeps. Okay, so that is the importance of how to collect the sample. And the sample size, of course, is important. As more and more powerful studies will come in only when there is good sample size. So this is the basic idea that you should understand regarding sample and sampling frame or sampling methods and the sample size. And with this few words of just an overview of the topic, I pass on to Dr. Ashok Reddy Garu, who will introduce the topic. The speaker, who is Dr. Vidhu Kumar, is my colleague also. And I thank the office bearers and for inviting me to chair this session. And over to Dr. Ashok Reddy.
Very good evening, Dr. Harish. And we appreciate the IPS South Zone's efforts, starting from the beginning, which is the first branch to start the efforts in research methodology. And we should recollect that Shaji is a person who has really sown the seeds for this particular compartment of our South Zone activities. He has worked on, and then Dr. Ashok is carrying on with a good perseveration, which is giving very good results to us. And we appreciate Dr. Ashok in selecting Dr. Vidhu Kumar for today's topic, an apt person for today's presentation. He is additional professor of psychiatry at Government Medical College, Ernakulam. And he has all the attributes which make today's presentation more useful to us. So basically, he's trained in clinical epidemiology. Then he's also trained in medical education technology, that he knows how to deliver his lecture to the audience in a more effective way. The second component, what he has, it's not only that he has interest in the particular area of clinical epidemiology. It's not just a theory background, it's also interest. He's also having more than 20 publications in various journals That is, he has experience even to know out the output of even statistics is there. So with all these three attributes in him, Dr. Vidhukumar is going to deliver us a more effective and useful sampling and sample methodology study to us. With these few words, I welcome Dr. Vidhukumar to start his presentation. Welcome, sir. Dr. Vidhukumar, please.
Okay. Good evening, all. At the outset, let me thank the office bearers of IPS Outzone for giving me the opportunity to deliver this talk. Also, I thank the research capacity of a group of IPS Outzone. Also, I welcome all the participants who participate in this program. Actually, you should see this talk as a continuum of what had been done yesterday by Professor T.P. Sudhagar, and probably he had given the initial ideas of sampling. Am I audible and the slides visible? Am I audible and the slides visible?
Yes, sir.
Sir, you can go ahead.
Yes,
Okay.
yes,
Yeah,
Dr.
we can go ahead, sir.
Yes,
Yeah.
Dr.
Okay. So taking from his lead, I want to build up this topic. First is, I have two objectives in mind while preparing this topic, and they to address the person who are view this, or the learner should be able to address sampling issues and sample size calculation while designing and reporting a study, of course, with the help of a statistician. And also, another purpose is critically evaluate research article for the adequacy of sampling method and sample size. These are my objectives for the current session. Okay, sorry. There is a delay in coming. Okay, my main topics I'm going to cover is, initially, as Dr. Harish sir has said, I'll be giving the idea of what's the importance of sampling and sample size. I will then consider sample in reference to the population and some terms regarding sampling and the different types of sampling and sampling issues for specific study designs, the basis of sample size calculation, and sample size calculation and description in different study designs. These are the areas I'm going to cover in this topic. Before dwelling into the topic proper, we should know that there are two things. One is there is a sample estimate. For example, if you are doing a study of alcohol use disorder in 1,800 male adults, if the percentage comes as 5%, this is the estimate from the sample. But the investigator had the objective of finding the prevalence of alcohol use disorder in that state. So he wanted to get the prevalence in the state, and that is the population parameter. So every researcher wants to project the sample estimate to the population parameter. Is it possible? So the sample estimates could be mean or mean difference, odds ratio, risk ratio, effect size, correlation coefficient. All these could be calculated based on a sample. But is this estimates calculated based on the sample, is it a valid representation of the population? That's the question. So, is this 5% represents the prevalence of AD in that state, alcohol use disorder in that state? Is it a true estimate of the population? There are two possibilities. Is it because of the specifics of the sample chosen? So, the importance of sampling method comes in. So even if a sampling method is okay, adequate, perfect, but there could be a chance factor or a random error, and statistics and sample size comes to your help. And the third possibility is measurement of alcohol use disorder or measurement of any variable, which my subsequent speaker, Dr. Vijay Raghavan, will be speaking about. Now, I will be putting the sample from the perspective of population. See, I want to study subjects with suicide attempts. Maybe in Kerala, or maybe in South India, or maybe in India. So my target that is the universe. That we can consider that as the universe. See, but what we do is that we actually are probably in a particular area, and we have the population which are specific to that particular area, that is the source population. For example, if I embark into a study of suicide attempts in one of the medical colleges in Kerala, I will be having the source population as the population catered by the medical college. That's the source population. And from the source population, subjects with suicide attempt attending medical college during a particular time is the study population. From the study population, we are choosing a sample. And if this sample is perfect, and the probability of finding this sample as representative of the total population, the study population, and by way of it, the source population, we can call that there is internal validity, except for the measurement. Measurement I am not discussing, otherwise sample has validity, internal validity. But my aim is to project my findings to the state of Kerala or to the state of India, to the country of India. So my universe, I'm projecting to the universe or the target population. So that is based on abstraction, based on the characteristics of the population, other research in the area. I will be trying to project my study findings to the target population, and I'll be giving external validity. So this is how sample and population are related. So if at all, if we are not correctly taking a sample from the study population, or if we are not taking a study population properly from the source population, what we are going to get is a selection bias, as Dr. Harish has said. And related to that, probably we need to, there is a problem which could be addressed slightly in sampling, but it's occurring in nature, that is the confounding is also. So these are the two threats to internal validity which could be minimized by the sampling, but they are the selection bias mainly and confounding minimally. And information bias is based on the information, this measurement. Now, so I said the problem will be at the selection of the source population. For example, if I am studying suicide attempts in one of the medical college in Trivandrum, government sector, there is a possibility that all suicide attempts may not come to a government medical college because of the socioeconomic strata differences, and maybe based on the stigma, concealment of their suicide attempt, they may not come to government medical college. Actually, there is a problem with the source population. And even from the source population, you are taking from the source population, you are taking a study population, and the study population maybe, for example, if you will not a particular time of the month or say a particular season or something, there could be some variation. And if you are not properly choosing a sample randomly from the study population, again, there could be error. And the exclusion and inclusion criteria are also important, which could be important in minimizing confounding as well as to perfect the sample to the population. So these are diagrammatically represented as sample deviating from the source population, and also there are the errors in the social population, etc. Now, some terms. One is the sampling unit. Sampling unit is the basic unit we choose for the sampling. For example, children under 5 years as the sampling unit. Sometimes it may not be individuals per se, it should be hospital discharges, maybe the sampling unit. It could be health events, maybe the sampling unit. So sampling units can vary. Then another concept is the sampling fraction. For example, if I want to take 100 children out of 2,000 students in a school, the sampling fraction is 5%. And this is very important to design or to make a proper sampling procedure. So this is known as the sampling fraction. Third related thing is the sampling frame. Sampling frame is list of all the sampling units from which sample is drawn. For example, maybe the number of households in a panchayat, the healthcare units in a state, the children under 5 years who are registered to an Anganwadi or similar sector. So all these are the sampling frame. And sampling scheme is method of selecting sampling units from the sampling frame. And it could be random. Yesterday it was referred to as probability sampling, or it could be a non-probability sampling. Now coming to types of sampling. So I'm not going into, already yesterday it had been discussed about the random sampling. I will be giving an example of how a random sampling can be done. See, I want to take 30 children out of 100. This actually I had minimized the figures just for clarity. 30 children out of 100 population, which is the source population. And the lowest value is 1. I wanted to arrange them as 5 columns. And I had used a software to generate the random numbers. And I had this random sequence. So I will be able to take 30 children based on the number will be, because here there is a sampling frame. From the sampling frame, I had numbered each of the sampling units in the sampling frame, and by computerized procedure, I had taken the random numbers, and this forms the basis for random sampling. Advantages of random sampling is simple, but the problem with random sampling is you need to have complete list of the units. Means you need to have the complete sampling frame. Only then random sampling can be done. Sometimes, for example, the population may be consisting of different strata in religion, socioeconomic status, geographical region. So sometimes random sampling may not be able to give the best representativeness. And another important problem is that if at all you are not, a physical survey is done, the units may be scattered and poorly accessible. For example, if I am doing a survey in Kerala, I will be traveling. If I am doing a physical survey, I will be traveling from Trivandrum to Kasaragod. So it is totally scattered and it is poorly accessible. So this is regarding random sampling. So coming to systematic sampling, select the sample at regular interval based on a sampling fraction. Yes, you remember what I said about sampling fraction. I will be demonstrating it. And advantages are simple, and you need complete list of units. Again, sampling frame is needed. One of the disadvantages is that since at the regular intervals the sample is being taken, certain periodic measurements, so periodic, for example, the sample may come every Friday or every Thursday, or similar periodic elements can come into the sampling. So this is an example of how a systematic sampling is done. I am taking sample from 2,000 population, and I want a sample of 100, and the sampling fraction is 5. I need a list of persons from 1 to 2,000 and randomly select a number from 1 to 20 as the first sampling unit, example 8, and the first person select 8, and add 5 to 8, and the 13th will be next one, and 18th will be the other one. Likewise, I'll be able to complete total 100 subjects based on systematic sampling. Now coming to stratified sampling, I said one of the problems with random sampling is adequate representation may not be able to get from a random sampling. For example, take the example of Kerala. Kerala has an urban area, rural area, coastal region, tribal region, etc. If you are doing a population survey, probably I need to create strata based on geographical regions. Probably many other things also should be considered: age group, occupation, geographical regions. And I need to take homogeneous subgroups or strata and from random sample from each strata. And advantages are an adequate information of the whole population and individual strata. And if there is homogeneity within this strata and between strata, we will be able to get a better precision. And the disadvantages is which are the strata to be identified is the only issue. Which way we should stratify. And loss of precision. For example, if I take tribal population, it's small numbers from that individual strata. So what we can do is that you can make a proportion probability sampling. And for example, if I do a study on dyslexia, learning disorder, I may take how many CBSE students are there, how many ICSE students are there, how many state syllabus. And based on the proportion, I'll be choosing the strata, and due weightage will be given to the strata for calculating the population. So this is known as the stratified sampling. The next is the cluster sampling, and the sampling units are not individuals, but the cluster in a group. It provides logical advantage. It's very easy to conduct because if I travel to one particular area, I'll be able to cover that geographical region and around 50 to 100 households, and I'll be taking individuals from that group. So it provides logical advantage. And the whole population is divided into groups or neighborhoods, and a random sample taken out of these groups, and within selected clusters, all units, example households are included. I'll be discussing this cluster sampling in detail when I discuss about multi-stage sampling. And this is how the cluster sampling works. I take a cluster from one area, section 1, another from section 3. Likewise, I'll be collecting all the households and take individuals from these households. This is how the cluster sampling is done. Advantage is simple as complete list of samples. Another thing is that sampling frame is not required. You only require the household list, and less travel and resources are required for cluster sampling. Disadvantages is potential problem is that one of the problem is that the members are in a cluster. For example, 50 households together, there are certain common characteristics, shared characteristics, which will be biasing our estimate. So there is a homogeneity. And in order to address that, we need to calculate something known as a design effect when we do a cluster sampling. Now, I'll be dealing with multi-stage sampling, which Professor P.P. Sudhakar left out yesterday. Actually, I wanted to take 200 subjects from panchayats, and the total population, I had minimized the numbers. The numbers may be huge. Just for example, total population is 8,940. And we need to identify 4 clusters, 50 each. And the sampling fraction is, basically, it is based on the households or the clusters. Actually, it is 2,229. Now, I will be randomly choosing one cluster, one ward of the panchayat as the first one. And this is the population, and this is the cumulative frequency. Now, first A is taken, then I add 2,229 to the 998 and take the next cluster, and again add 2,229 to the next cluster, and finally I had chosen 4 clusters A, C, E, and H. I had taken 50 adjacent households are taken, and I had chosen one individual from the household. How to choose one individual from the household? Again, there is a random method. You can use a lottery method or a KISS table method, etc. Again, a randomness should be there for choosing. Another issue is that you should visit that house at a time when all members are there. And also, you need to make repeated visit to ensure that that member is covered. Otherwise, there will be a lot of bias could creep in your data. This is known as the multi-stage sampling. Here, I had combined the random sampling, cluster sampling, and again, systematic sampling, etc. had been considered. So this is how multi-stage sampling is done. So I discussed the different sampling methods. Then I will be going into the sampling based on the designs. See, if I want to do a case control sampling, what I will be doing is I will be taking cases Cases, for example, I assemble cases coming to a medical college. There is no particular, especially usually case control is done for rare cases. So I will be assembling all cases. But the problem is that we need to ensure that the control should come from the same population as the cases had come. That may not be explicit, but you should implicitly, it should be made sure that the controls are coming from the same population as the cases had come. And one epidemiologist has said, if at all a control has developed a caseness, he should come in the case list. Likewise, it should be from the same population. Otherwise, there will be bias. I remember I will be giving an example. For example, perceived stress and suicide had been done in nursing students. Actually, attempted suicide was done, and the perceived stress was done in a study among adolescents. And the controls were chosen from the nursing students. So what happened here is, the study was done in a medical college patient population, and controls were chosen from nursing students for the perceived stress. The controls departed totally from the cases, and whatever you get is waste. Now, coming to the cohort sampling, again, you are taking exposed from the population and non-exposed from the population, the same geographical region, and you are following it for the outcome. Here, actually, again, the importance is the development of outcome measurement is more important in the cohort sampling, and the control and case selection, the exposed versus not exposed selection is not that problematic in the cohort sampling method. One of the term which is often confused with randomization is random sampling is random allocation. When you do RCT, usually what you do is not random sampling, what you do is a random allocation. From the patient population, you are randomly allocate individuals to either to the intervention group or the control group based on a random number generated. Means it will be fixed a priori, and there it will be concealed. Only the head office will be knowing who is going to go to the intervention arm and who is going to the control arm. And there is blinding. And that is known as random allocation and allocation concealment. Now, a word about non-probability sampling. I'm not going into detail. Non-probability sampling is basically not a statistical sampling. It doesn't address sampling error. The purpose here is getting the richness of information, and usually it is reserved for qualitative studies. And Professor T.P. Sudhakar had explained the various types of non-probability sampling. I'm not going into details of that. So I had covered the first part, as Dr. Harish said, how to do a sampling. Now I'm going to the second part of my presentation, that is calculating the sample size. Again, I had taken a good sample, perfect sample. I had discussed, I had considered so many factors so that there is no selection bias. The sample is a perfect representative of the source population, and I can project again to the external population, and external validities also may be possible, but there is a chance factor still. So statistical analysis and the comes to your help. And I will be, one of the key components in the statistical analysis is the calculation of the sample size. See, this distribution is familiar to all of you. See, this is the normal distribution, and there are different types of distribution based on the normal curve, the sampling distribution, standard distribution, etc. But don't go into those details. This is just a normal curve. And basically, this is ideally, it should be called a sampling distribution of means, is the ideal name for that. But what I'm doing here is that when I'm comparing two groups, or actually the first group is the control group and the second group is the case group or the intervention group for the current example. And the null hypothesis is that the control group, the intervention group and the control group will be similar. And the alternate hypothesis is that they will be dissimilar, and there is a difference. It departs. So But when you plot normal curves for these two hypotheses, there is an overlap. Means there is one blue area shown here is actually the alternative, when we are entertaining alternate hypothesis, the null hypothesis encroaches into the alternate hypothesis area. And this is known as the type 1 error or alpha error. Similarly, what happens? The reverse also happens. Erroneously, we are concluding that the null hypothesis is true and alternate hypothesis is false. In this conclusion, there is an error which creep in, and that is known as a type 2 error or the beta error. So these two errors are important for sample size calculation. And again, making it more explicitly, for example, if there is a difference according to the actual truth, and based on the study finding also there is a difference, this is a correct result. There is no difference according to the actuality as well as based on the study finding, again it is a correct result. But when the study shows that there is a difference and there is no difference in reality, it is not, and you will be having a wider confidence interval. It may be significant again, but you have a wider confidence interval. But there is a difference in actuality, but you are erroneously concluding that there is no difference. This is known as type 2 error or beta error, and you are having an inconclusive confidence interval and even insignificant statistics. So these are the two errors. So coming to this curve, again I had taken the first curve. Here actually the effect size for the purpose is taken as 94, and you are seeing that the beta error is large and the alpha error is again not that problematic. Take this one. The basically the mean of the alternate normal curve is 98, and actually the alpha beta error has come significantly, and alpha error is also reduced. So what I'm trying to say is that when the effect size increases, the power increases. The power also goes up. And also, there is a possibility that if there is a variation, the curve will be something like this. Again, the beta error will be more. And by increasing the sample size, you can make the curve cavity, and the beta error and alpha error could be minimized. So this brings us into these things. Basically, there are 5 attributes. One is the sample size. Second is the variance of measurement, standard deviation and precision, and clinically significant effect size you want to detect, assigned value of alpha error, and anticipated power. These 5 variables are interrelated, and we are using this relationship in sample size calculation and to maintain, for example, for a particular alpha error, for a particular power, we are calculating for a particular effect size, and for this variation of measurement, the sample size is calculated. This is the basis of sample size calculation. Where do you get these parameters? One opportunity is literature search for summary measures. For example, measure of effect as well as variance, you can get from the literature. One thing I want to tell you is that the statistician will not decide these parameters for you. You need to find out and report to the statistician, okay, these are my parameters. This is my effect size. This is my variance. And this is this beta, this alpha error I want, this beta error I want. So another opportunity is pilot study. Doing a pilot study and getting the measure of the effect size as well as the variance. And the third possibility is expert opinion. And the most important thing is what is the clinically significant effect. For example, a change in HDRS by 2 or is not significant. How much is a significant difference that you can get from the expert? So these considerations should be taken into for when you calculate sample size. When do you calculate sample size? Definitely before, at the design stage. When you make the protocol, you need to calculate sample size. But in certain situations, probably you may truncate the study, or you may extend the study depending upon the sample size, very rarely. But after the study, it is seldom done, but there are 2 reservations. One is that it's a debated topic. You can do a post hoc power calculation based on the sample size. And also, when there is no significant finding, you can go for a non-inferiority trial, non-inferiority analysis, in which probably we want to prove that the intervention arm is not worse than the control arm. And for that, you need to do a non-inferiority analysis sometimes after the study. So these are these. Ideally, it should be done before the study. Explicitly, it should be calculated before the study. Now, I will be coming to the sample size calculation for designs quickly. And this formula everybody knows. And this is for sample size calculation for a prevalence study. And here, the values chosen are basically the standardized normal deviate, which is an extension of alpha error. And P is the proportion of prevalence of interest. Q is 100 minus P, and these P, Q, and D are precision and the effect size. And for example, the prevalence of alcohol dependence in the population reported is 5%. A study with cluster randomization is planned for 95% confidence limits and 25% precision. Calculate the sample size. Reduce EPI to calculate the sample size initially without clusters. 5% as the prevalence and 1% as the precision, because 20% I had taken, and 1 lakh as the population, and with one cluster at approximate sample size is 780. Now, I calculated the sample size. I said about the cluster effect. 38 clusters I had taken, and design effect of 2 is being given, and 1% precision and or confidence limits, and 5% prevalence. The sample size is approximately 1596. So I'll be reporting this sample size in a prevalence study as for 5% prevalence and 20% precision, and for 95% confidence limits, they're allowing for the cluster effect of 2, sample sizes calculated to be 1596. 38 clusters were formed with cluster sizes 32 each. This will be the reporting format for a sample size calculation. Now, I will be going to cohorts. Cohort is actually comparing proportions. Here, P1 is 20% in the non-exposed group and 40% in the exposed group, alpha error of 0.05, and for 1:1 exposed to non-exposed ratio and the power of 50%, the sample size is calculated to be 51. And this is a power curve constructed on R. And you can see that when the power goes up 80%, the sample size is approximately 100, which is double of 51. And this is a case control sampling, sample size calculation. Again, I had used EPIinfo. Power is 80%, and the ratio is 1. 1:1 case control ratio, and 30% of exposure in cases, and 2 as the expected odds ratio, and sample size is calculated to be 141. The reporting format would be like not this study. The reporting format for a case control study will be for 2:1 ratio of cases and controls, 95% confidence intervals and 80% power, with the prevalence of alcohol misuse in the population, expected odds ratio of 2.5, sample size is estimated to be 76 cases and 150 controls. Now coming to RCP, it's actually a difference between two means. Here it's blood pressure. 10 is the difference, 20 is the variation, alpha as 0.5 and power as 0.2. I constructed the sample size is found to be 63, and this is the power curve. As the if you're taking 90%, this 90% as power, the sample size will be approximately 85, 90. Now I made a modification to the previous one. Instead of the effect size of 10, I had taken 5 here. I reduced the effect size. See, the sample size escalates to 250. Again, in this, I had increased the standard deviation or variance to double again the sample size. So I'm trying to say that the important parameters are, one is the effect size, the variance, the alpha error and beta error are the important aspects when you consider sample size. In categorical also, this is actually 10% among the cases, 10% improvement, 20 among the controls, and 20% improvement among the intervention arm. not control, comparator arm. In the intervention arm, 20%, alpha 0.5, 80% power. The sample size estimated is 290. So how to report a sample size in RCT? To detect a reduction in PHS, post-operative hospital stay of 3 days, standard deviation 5 days, which is in agreement with the study of so-and-so, with the two-sided 5% significance level and power of 80%, a sample size of 50% per group was necessary, given an anticipated dropout rate of 20%. To recruit this number, the patient approximately 12-month inclusion period is needed. This is the way in which probably a consort statement needs the description of a sample size in an RCT. And coming to the last few slides. So what I'm trying to say is that when you do a proper sampling, you are actually, and the measurement, you are actually eliminating the systematic error. The parameters will be congruent and there is precision. But when there is a random error, actually what happens is there is no precision and the parameters will be distributed scatteredly. So what we need is, we need to eliminate random error as well as systematic error. We need to have an estimate which is very closer to the truth, precise and valid. And that is why sample size and sampling is important for a researcher. And finally, caveats. Already I said about the cluster effect. You need to calculate the cluster effect. Cluster effect is not 1.5 or 2. Ideally, a statistician should decide what is the cluster effect for the study. And another thing is the non-inferiority trials. When there are no difference between the intervention arm and the control arm, basically we need to consider the non-inferiority analysis, and that is slightly different, which is beyond the scope of the presentation. Masked designs, probably the sample size calculation may be, sample size may be different in masked design, and the sample size is likely to be more with the masked designs. When there are multiple independent variables, as in a case control study, how will you calculate sample size? Ideally, what you need to do is that you need to list out all the variables, and you need to calculate the sample size for each of the variable based on the H1 and the alternate and null hypothesis, and you need to take a most important, clinically important, or a feasible sample size you need to take. When you do comparison between multiple groups or post hoc analysis, there should be an adjustment for the p-value, and again the sample size should be escalated a priori. And another issue is the non-response or dropout. Whenever you calculate sample size, especially in a cohort study or an RCT, you should calculate or anticipate non-response and dropout and adjust. Usually a 10% or a 20% increase in the sample is mandated. And sample size is very important because negative studies are seldom published and they go into the dustbin or in your suitcase only, and that will lead to publication bias. And even in a meta-analysis, probably that may create problems. That is why all randomized control trial needs to have a registry register. So with this, I conclude my presentation. Thank you once again for all the participants and the South Zone office bearers, as well as the research capacity building work. Thank you.
So,
I had finished my presentation.
Yeah, okay. So I think Dr. Vidhukumar has made a very good presentation and the topic has been covered. Maybe there are some issues which students may be wanting to ask, maybe some points to be clarified. So it's open for discussion. I don't think there are questions have come in the chat box. So if anybody wants to ask anything, we can you can ask. Meanwhile, one point I would like to ask Dr. Vidhu is, see, there are so many the students for the postgraduates, they need to do their thesis. So they will have to do a statistical, I mean, the sample size calculation by them. So what are the resources available, like online resources, etc., which they can use based on majority of the studies probably would be kind of cross-sectional studies, maybe some case controls. So based on this, what would be the good online platforms or softwares available, which are free softwares available for doing their
Okay. Okay. Softwares are many, but the most important thing is that you're choosing. I said about the 4 parameters. These 4 parameters, they need to search in and get these 4 parameters for the study. Then they can use free softwares. One of the important free softwares I use for case control study and prevalence studies, EpiInfo. EpiInfo is actually a CDC sponsored public health, it's in public domain. And there is a StatCalc option in that, and you can use the sample size calculation for that. You can do that for case control study, prevalence study, as well as cohort study. And also, we can use sample size calculation based on R. R is a good platform, but the only thing is that only trained people will be able to. I do my sample size calculation based on R. R has a beautiful sample size calculation. I had demonstrated the power curve. All these are based on R. The power curve building, everything is based on R, and they can use. And there are so many other softwares also. And SPSS, I am not very sure. Initially, it didn't have a sample size interface. Whether it has a newer version, whether it has, I don't know. And there are softwares. OpenEpi is another software where you can calculate the sample size. So these are there's so many open free software calculators. But the idea is that simply imputing some data into the software is doesn't give a proper sample size. You should know the basics of sample size, and the 4 parameters I had mentioned, you should just from the literature, and then only you should impute into a statistical software for sample size calculation.
So the 4 parameters are the alpha beta errors and
alpha beta errors and
difference or the mean difference or
difference. So effect size as well as the variation, standard variation, precision, etc.
So other questions are welcome. And does EpiInfo cover both this continuous category, both all the types of variables are covered in EpiInfo? Because
usually it's prevalence studies, epidemiological studies they do cover. Prevalence studies, case control and cohort. Mean difference, etc. they don't cover. And diagnostic test evaluation also, you need to have different softwares. And again, based on proportion also, you can manually calculate the sample size calculation in diagnostic test evaluation. Actually, I wanted to include that. I thought it'd be difficult. Already a lot of mathematics is there. I don't want to confuse further.
So first they have to download EpiInfo from the CDC site.
Yeah. The latest version could be downloaded from the
and
CDC.
It's a free software.
It's a free one, and StatCalc could be used as the for the sample size calculation.
Okay.
Can I ask a question, sir?
Yes.
You have mentioned all that in your slides, but for the PG's sake, for different study designs, when they approach the statistician, what all information should they provide other than alpha, beta for cross-sectional studies, case control studies? What all information should the PGs have? You have mentioned that in the slide, but just to highlight that.
So taking the case control study, for example, case control study, actually, although we are want to explore the relationship between one risk factor and the outcome, the caseness, there may be multiple other variables which are confounders we'll be considering in the design of the study. So what we should do is that we should go to the statistician with all the independent variables and the likely risk effect size of these independent variables to the statistician. And you need to also give, for example, in case control study, you can have a ratio of case to controls is up to 1:4. So based on the feasibility, for example, if in your setting, if you are getting more cases, for example, 1:1 case control is okay. But you are getting less cases and controls are abundant, you can choose 1:2 case, 1:2 or 1:3 or 1:4. Beyond 1:4, there is no benefit. And what ratio you want to take, and also the risk ratio, the odds ratio, anticipated odds ratio you want to take. If you are giving, for example, feasibility, 2 is the optimum odds ratio. But if you, for example, in a PG study, probably the sample size may not be adequate, so we can go up to 2.5 or 3 for the odds ratio. And also alpha and the alpha error is universally decided as 0.5 or 95% confidence interval, and the beta error as usually as 80%. So what, and you need to give, and also what is the clinically significant? How much, for example, what does the guide ask? What odds ratio you want to find out, anticipate, that you need to give to the statistician. And okay.
Some questions have come. One is it mandatory to register a case control in the CTRI, which I think is not needed. I think only
actually it is said that you needn't register case control to CTCRI. All RCT should be registered.
RCTs only. It's only for clinical trial.
But you can register a case control at cohort also. Because intervention studies also could be looked by both cohort as well as, for example, observational cohort of an intervention.
Yeah, that is agreed. Cohort studies definitely can have an interventional level.
Again, RCT also.
Case
control is the outcome as the caseness is outcome as the response, mortality or improvement as the caseness. Then you can even compare some of the interventions in a case control design also. So you can register. It's not mandatory, but ideally you should you can register in clinical trial.
Another question is regarding what is design effect.
Design effect already I said, because the best optimum or ideal randomization strategy is the simple random sampling. Means the sampling error is totally eliminated. But for feasibility and logistics, what we do is that we go for cluster sampling or stratified sampling. So what happens is when you take stratified or cluster sampling, actually these clusters, in the clusters, the sampling units, which are the individual, are they together? So there are so many factors, socioeconomic status, health-related factors come together in the cluster. So that will produce some bias in the cluster sampling. So based on the homogeneity of the sampling, the statistician calculated an indicator to circumvent this homogeneity effect. That is known as the cluster effect. And usually, the statistician ideally should calculate it based on the homogeneity in the sample. But it's a very cumbersome procedure. So what usually is done is that you can take a cluster effect of 1.5 to 2. But that is not a foolproof method.
Another question is sample size for descriptive studies and correlational studies. I think they may be meaning cross-sectional studies, maybe descriptive. I'm not sure.
Basically, probably descriptive is the prevalence study. Correlational studies are basically the observational analytical studies are probably referred to as correlational studies.
Correlational, we also talk about those ecological designs and all. No? That's also taken as
okay. But I think the correlational studies in the social sciences paradigm is primarily observational analytical studies are taken as the correlational studies. Ecological studies actually basically I don't know about the statistical calculation of the ecological study. Basically, you are comparing two summary estimates.
Aggregates, population level.
Population.
Yeah. And descriptive studies and what is this? Maybe descriptive study actually, it could be what they mean, maybe the cross-sectional design only, no?
Yeah, cross-sectional. That is the prevalence. It's almost like
what is usually done by that
prevalence. means finding a proportion. Finding a proportion is based on the prevalence study method. And one of the common designs is probably comparing two groups for a mean difference. For example, quality of life difference between two groups. In such a situation, probably you can do a sample size for the mean difference. If it is a proportion difference, you should use the sample size calculation for difference in proportions.
Again, one question is how to calculate sample size, which I think is a very broad question.
I had a sample size based on the design, and I said.
I think there are formulas. We can have 3 or 4 types of formulas based on the study and the variable.
Okay, but the formulas were in the olden days. Now there is no need for the formula. Once you have the parameters, so the software gives.
Software. But they should know the type of variables and this other precision and
definitely.
Is important.
Can I ask a question?
Yes, sir.
Yeah, in a given suppose article, how can you identify there are errors in sampling method? Most of the time, the author doesn't produce those.
Ideally, the reviewer should, or you should look for the parameters the author had taken for sample size calculation. If it is not there, if you are critically evaluating literature, you should look for the parameters which are available in the literature and recalculate. You can recalculate the sample size and see whether the sample size is adequate or not. So that is the way in which, that is the only way. Actually, it should be made explicit by the author in the manuscript, how the sample size is reached. But if you're critically evaluating, you need to look into the parameters and recalculate the sample size and probably saying that whether the sample size is adequate or not.
Questions are design effect has been already explained. Again, the same question is coming, and anybody else wants to ask any questions? Postgraduates, I think they're mostly silent. I don't know whether they find it difficult to understand or have they understood everything. It's not very clear. I think majority of please.
Sir, the delegates postgraduates, they are not in this platform. They cannot be seen on video. They only post the questions and we have to copy it and paste in the chat box. That the technician is doing.
Yeah, but very few questions have come in the chat box.
Yes.
That box has not given many questions. So I think most of the time postgraduates will be doing either case control or cross-sectional studies. So maybe that is what is more important to be. They have to understand how to do the sampling and sample size. I mean, very often in practice, what happens is whatever we say about the sampling, what happens is they collect the sample when they are on duty or when they are available. Other days, they don't collect the sample. So it's not a very systematic way. So what do you say about that? In practice, that is what we see. Okay, they are posted to some unit and they will come to the place where they have to collect a sample on maybe some days a week, not every. There's no definite pattern or anything. It's just kind of we cannot call it random, because it's just going on like that. So I think, and
But,
they may
if-
not take all the cases on any given day also. Some cases they will take, because collecting the data itself is cumbersome. It takes maybe half an hour, 45 minutes, or even sometimes more than that. So will it really affect the kind of outcomes, or how can
Yeah,
we do that?
but actually regarding case control, there is no problem because taking cases, you can assemble cases in any way. For example, you are going, for example, if you're working a suicide attempt as the cases, you can assemble 100 suicide attempts and there is no need for any logical order or a randomization or etc. for cases. But you need to ensure that the controls are taken concurrently, and they come from the same population. Means you need to take controls from the same hospital where the cases had come, so that from the same population it has come. So you can take controls. You can, for example, you can every admission day you can take if there are 2 case suicide attempts, 2 controls could be taken on that day from a random list of if it is matched depending upon the matching criteria based on gender or age, or otherwise you can take from the admission list randomly. You can take 2 cases on that day or the next day also. Likewise, you can assemble the cases and control. There is no strict guideline as such in taking random selection of cases and controls. But regarding control selection, probably some amount of randomization you can apply in case controls.
So 2 questions have come up. One is regarding what is that? Can we take any arbitrary D value margin of error? That is one question. It's not very clear to me. I think is it precision? What she means is not clear.
For precision.
Yeah. And another one is how to calculate sample size for descriptive study. Are any free software to calculate? I think they are not listening what we are saying. Again, the same questions are being repeated.
Okay.
That is free software, and again somebody is again going on asking about design effect. I don't know.
See, D value is actually already said. Usually, conventionally, the D is taken as basically 20% or 10% of the primary effect size is taken as the D value. But that, for example, if you want to have a better precision, probably you need to go for a 10% D. If you want to have less precision, you can go for 20. And you can in postgraduate studies probably you can be flexible and you can go for 20 for the feasibility of the sample size.
Okay. Same question again. That is a descriptive study. How to calculate
that already said.
Already explained. You have to use the software. And somebody has again asked about software. Once again, I'm just repeating what Dr. Vidhukumar told. Software, you have to download EpiInfo from the CDC website. It is a free software, and there is StatCalc in that which you can use to calculate. Or else there are many other. I think Epi. What is that? Epi.
OpenEpi.
OpenEpi is another software which is again you can use, but you need to know these 4 parameters before you put that value. Okay. So there are no more questions. I think we can wind up. Dr. Ashok Reddy Garu, I think.
Yes, sir. It was an excellent presentation from Dr. Vidhukumar. We have learned so many points from this, but statistics for average clinician is usually if you cannot grasp more than 50% of what the presentation is. Again, if you listen again, we'll grasp another 50%. So probably we have to listen repeatedly to grasp more and more statistics subject. The subject is like that. Probably we should have more and more such sessions. We are grateful to Dr. Vidhukumar for giving a wonderful presentation. I think we can close with this.
Thank you, sir. Thank you, sir.
Okay.
Thank you, Vidhukumar sir, for that lucid talk. And thank you, Harish sir and Ashok Reddy sir for sharing so efficiently. Now we move on to the second talk of the day, that is basics of statistical analysis and working with a statistician. The speaker is Dr. A. Ramesh, Professor Otorhinolaryngology, Head and Neck Surgery, St. John's National Academy of Health Sciences. The chairpersons are Dr. N. Nageshwar Rao and Dr. K. Ramakrishnan. Dr. N. Nageshwar Rao is Professor and Head of the Department of Psychiatry at Sri Venkateshwara Medical College, Tirupati, Andhra Pradesh. And Dr. K. Ramakrishnan is the Consultant Psychiatrist at Atma Hospitals and Research. He's the past President of IPS Tamil Nadu State Branch and also the President-elect of IPS South Zone. He has won many awards, has many publications to his credit. I welcome both the chairpersons to the program, and I hand over to the chairpersons to introduce the speaker and the topic. Over to Dr. Ramakrishnan, sir.
Sir, you're muted, sir. Dr. Ram.
Good evening to all of you. I thank you and the organizers for giving me this opportunity. This topic is research, basic statistics, working with the statistician. It cannot be overestimated that this is the root of all our topic, all our discussions and all our science, what is happening today. If you say there are treatment gap of 85% in psychiatric patients in India, that is a statistics. If the average depth of a water canal is 10 feet or 20 feet, then it is statistics. Everything is statistics. So I usually, when I make it a point that all our DMB postgraduates work with a statistician in our institution to make the dissertation, because many things we can assume other thing, but final clear message can be given only by a statistician. And we have got a good team of statisticians in Bishop Weber College, local colleges. They are all helping us out. And I understand the value of statistics. And the students should take an interest in knowing the statistics. And another point, what I have seen over a period of years, they attend the lecture and then stop it. Unless you do the research, then only you will apply the statistics and then only you will remember. Doing is remembering. Attending one day class or 2 days class is not enough. You have to put into practice. That will be my request. And I request the delegates to keep posting the questions then and there, so that it can be cut and paste to the speaker column and we can have good interaction. I request Dr. Nageshwar Rao Garu to introduce Professor Ramesh, who is a ENT surgeon, someone out of our batch, but a good clinician and a statistician.
Thank you, sir. And I welcome Dr. Ramesh. At the outset, I would like to congratulate or convey my wishes to all on the occasion of World Mental Health Day. So this is a very good day for us all to have this session. And our speaker is a professor of otolaryngology, head and neck surgery at St. John's National Academy of Health Sciences. And he has done his post-graduation at AIIMS, New Delhi. And he has been trained in molecular biology, medical intelligence, and language engineering. So his accomplishments in academic focus areas are early detection and rehabilitation of hearing impairment and noise reduction technologies. Research methodology training, he had led the team to conduct research methodology sessions for National Board of Examinations and St. John's Medical College. The team led for 90 workshops. So designed 15 innovative teaching aids, designed an education application, Research Genie, hosted by Play Store and App Store. So I think we have the right person to talk about this topic, which is very crucial and which is most of the PGs or who are doing research, they find it very difficult to handle this. So I think it's a very good topic and we have a right person for this. I request Dr. Ramesh to start his presentation.
Very good evening, all of you. Yeah, I'm Dr. Ramesh here. And at the outset, I thank the organizers for giving this opportunity to interact with senior people in the specialty and as well as the postgraduates. And thank you, Dr. Nageshwar Rao and Dr. Ramakrishnan for that generous introduction. Just to check certain things, my voice is clear, right?
Yes, it's clear.
And presently I am seeing there are at least in this is showing as 14 participants. And what I heard as the lecture was going on is there is a platform on which the postgraduates are on, right?
Correct.
Yes,
Dr. Ramesh, we have nearly 208 students listening to you.
Okay, got it, sir. So, what has made me passionate about research, which I know I specifically want to share with the students and the faculty, the statistics it appears like a serpent to many people. The moment statistics is mentioned or moment the analysis has to be done and things like that, people get a little worried and very jittery about the entire thing. So for the last 12 years, I should say, my mission has been to demystify this entire thing and make statistics easy to handle. In fact, really enjoy. Many people after doing some of our courses feel that they enjoy now statistics and doing research. So what I intend to accomplish probably by 7 o'clock is to get all of you all inspired about statistics. And I intend to use a tool because I believe there is no point of talking about the theory of statistics, about formulas is one thing which I have realized should never be put up on slides. The moment you put up formulae on the slide, doctors really switch off because that is what they have been running away from their entire life. And then here is another class where they again have to look at formulae or do some calculations. So what I would first recommend is, as I said, we use a tool. What I intend to accomplish at the end of by 7 o'clock is you get the ability to identify the major requirements for communicating with the statistician. So we'll structure it this way. First, I'll request you to download this app. It's a St. John's educational app, so none of you have to worry. It's on Play Store. Those of you are having Android phone, you go to Play Store and look for Research Genie. Okay, it's called our research as in research, Genie as in magic genie. So Research Genie. So those on Android can go to Research Genie. Those on App Store can again go to Research Genie. You put it on download and we can have a discussion as it downloads. So
Dr. Ramesh, sorry to intrude.
Yes, sir.
The spelling Genie, G-E-N-I-E, Genie. Yeah.
Yes, sir. G-E-N-I-E. I will share my screen so that. Okay, is my screen visible now?
No, sir.
Not yet, Doctor.
You haven't shared your screen yet.
I will take a few seconds and wait.
Sir, you have to share screen in Zoom.
I have done that. I'll do again. I think, is it okay now?
Yeah, it's come.
Your screen sharing. Okay, done. So as the app is downloading, I would want to listen to, or in fact, hear from some of you, especially postgraduates or even the faculty, what has been your difficulties while either doing statistics or communicating with the statistician?
We hope, Dr. Ramesh, they will start flooding the chat. Right now, they're not doing that. Maybe to start off, maybe you can, as questions come, we'll let you know. Yeah.
Okay, done. So usually, one thing I've seen people go to the statistician and they tell them, I want to do sample size calculation. And they will ask you, okay, doctor, what are you planning to do? They will tell we are planning to compare two groups. In one is, a nurse-led intervention, other is an institution-led intervention to look at how people with schizophrenia can be managed. The next thing that the statistician asks them is, can you tell me, how are you going to measure this outcome? So they may probably say that we are going to use this score to compare between these two people, or they may say that we are going to look at recurrence of an episode. Then the statistician asks them, how much do you expect the difference between these two groups? That is where real thing happens. They will think, my God, this is what I'm planning to do the study about. And this fellow is asking me, how much do you expect the difference to be? So that is where the major block comes, where physicians think that I'm doing the study to find this difference, but the statistician seems to be asking me the results of my study. That is one thing. Or they may be doing some kind of descriptive study where they will ask, I want to see what is the proportion of people coming with major psychotic illness in my OPD. So maybe that could be a descriptive study they're planning to take up. There again, the statistician will ask, how much do you expect? Can you give some ballpark figure of how many people come to your OPD? There again, people get worried. This is exactly what I'm planning to do, and this person is asking me the result of my study. So what I intend to do in the next next 45 minutes is to give a glimpse, or give a path which anybody who's planning to take research can get it by using this app. So you have this app for your lifetime, and you can keep using it anytime, anywhere. So those of you who download the app, maybe the faculty, someone here who has downloaded, can you just open the app? Dr. Indu, may I request you if you can?
I have downloaded, sir.
Yes, madam. So if you open the app, can you see the first page opens up? It's called R1, the Research Genie, St. John Medical College Research Society.
Yeah.
If you swipe it, ma'am, you go to this page. I'll just show you on this. You go to this page on the app. You have this on the app, ma'am?
Yes, sir.
Okay. So this is for people first to define which is the group of people they are working for. Many times, again, this is, many times because of lack of focus, when people go to the statistician is a little confused. So first thing that people have to define is they have to exactly define the target group. For example, I'll stick to schizophrenia, and you all can correct me. I'm just using an example. So if I'm technically wrong, you should correct me. People will tell, I want to find a new method of how to look at recurrence in schizophrenia. I want to see a new method of social involvement of people with schizophrenia. Now, that is not how you start with. You start with people with schizophrenia. That is the group I want to work with. So if you have your app, ma'am, this again for postgraduate, senior faculty, I don't think you may have to, this will be an issue with you, but first year postgraduates who are fresh in the specialty, madam, if you just tap on define your target population, you have a page like this open up, in which the first box defines the group of people, and the second box you have to enter what is the condition they are dealing with, and if at all they have doubt, there is a small circle at the left bottom corner with the query. If on tap on that, you have various examples come up. Newborns with congenital heart defect, adults with fracture of femur, adolescents with substance abuse, which is it's a psychiatric domain thing. That has come, madam?
Yes, sir.
Yeah. If you put got it, it goes back to the previous page, in which, just for the sake of a demonstration, madam, can you just tell what you would like to enter?
Elderly with dementia.
Okay, so you can write there, madam. Elderly with
dementia.
So this gives a clear focus from the beginning. Which is the age group? Elderly. With what? Dementia. So we can just enter that, madam, and then go to the circle at the right hand corner and put the tick. If you press, you come to the home page. You come to this page again.
Okay.
You come to this page, madam. Now if you see, the box will be written elderly with dementia. Correct?
Yes, sir.
Right. Now, next thing that you do is get a brief glimpse of the entire design of research methodology, so that wherever you have to interact with statistician, you can exactly show on the map, this is where I need support. Yeah, I will not go to the intention, but just for the sake of completion, if you tap on intention, madam, it just gives a broad direction to your work. That is, identify a challenging healthcare situation, perform a literature review to see if people have already answered the question that you're asking. If not, design a study. And the final thing is, again, for critically evaluating literature. There may be people, postgraduate, those of you who are there, some of you may say that I may not, research may not be my cup of tea. I may not want to, juggle with numbers, but knowledge of methodology, knowledge of how sample size was calculated, knowledge of how the analysis was done will give you the ability to check the credibility of the literature out there. Otherwise, anybody can take you for a ride. So again, go back to home, madam. Go back to home.
Yeah. And
then I'll show you a very innovative way of understanding the entire map of research methodology. If you tap on the design, this picture comes. The design of research methodology. You have this on the tab map?
Yes, sir.
Yes. So this is where in the universe you ask a question and then you take a sample. And because you take a sample, you have a type of error creep in. Here, one concept that you have to get is the two types of error, type 1, type 2. Type 1 has to be 5 or less, type 2 has to be 20 or less. That's all that you need to know.
Dr. Ramesh,
yes.
sorry to interrupt. Since Dr. Indu is helping out with the, can we ask, I'll request Dr. Indu also to come put the video on and just hold the app in front so that, we all are observing what is happening. So maybe, yeah.
But only serving the visible, I believe, sir.
It doesn't come. I try to show it on the screen. So it comes in a very mirror kind of thing. What is best for the learning is people can they can download, sir. That is what comes like this, but you can't see it clearly. People can. It just takes a few minutes to download. Downloading and being
okay. All right.
Improve the learning, sir.
Sure.
And all of you there, if you can just download the app and then go with it. I can wait for a few minutes.
Sir, it is Research Genie, isn't it?
Yes, sir. Research Genie.
Is it available in iPhone, sir?
App Store, sir. You have to go to App Store.
Okay.
And Research Genie. It just downloads in 1 or 2 minutes. Any questions from the PG? Any difficulties they have been voicing?
They have already asked one question.
I can answer that, sir.
The chairpersons can see the question. I think the chairpersons can see the question.
Yeah. But we'll first go to the app.
You can tell the question, sir, so that meanwhile I can ask people are downloading.
The question is how to communicate to the statistician, whether it is correlation or association or something else.
Okay, how to communicate to statistician, whether it is correlation or association. Fantastic. Exactly that. You keep telling me the question, sir, as it keeps coming, so that I can note it down. Professor Ramakrishna, is it downloaded on your phone?
Yeah, it is getting downloaded, sir. No problem. It is going.
Professor Nageshwar Rao?
Yeah. I am with the app.
Done. Okay. So this concept. So now this is clear. So the researcher knows that when the statistician is going to ask me type 1, type 2, I should be ready with. And what is minimum, acceptable, maximum acceptable is 5 and 20 for each of these. And I put as 5 and 20 because this is what is entered on the software. Software does not take us 5%, that is 0.05, or 20% at 0.02. Most of the software either take 5 or 20 or things less than that. Some software may take up type 2, they ask power, which again I put as power is 100 minus type 2. That again is there in this picture. So if it asks for type 2 error, you enter as 20. If it asks for power, then you enter as 80 or more. So minimum accepted is 80% power. Now, if people are writing an exam on statistics, probably you can try to understand this. But I keep on telling during my courses, please don't try to understand this because there's no use. What you need to know is how much of error you are willing to accept, which is a very clinical judgment. So I keep telling, if you are going to launch a rocket to the moon, a few 1,000 kilometers doesn't matter. Whereas if you are doing a work with the pH of the body, in 0.00 it matters. So how much of error you are willing to accept, it depends on what is at stake. And that what is at stake, it's only the clinician knows. So you have to decide how much error you want to accept. You cannot ask the statistician that you tell me, sir or madam, how much error. No. Maximum acceptable error is 5. And maximum acceptable error in type 2 is 20. So you can either, you can take a lower error, but you can never take a bigger error for any clinically relevant work. So that's how the sample size is calculated. And then the next step is to summarize your data in the form of, summary measures. Again, if you see the red means the central what is the value of central tendency, and dispersion around the thing, how is the data dispersed. And after you have done this, as the previous speaker, Dr. Vidhu Kumar, was nicely pointing it out, still there will be error, which is again taken care by doing the test of significance. So I have depicted the test of significance like a gate. So you push the data through the gate, which is done by software, and that brings out p-values. If the p-value less than 0.05, I put a green arrow, it can be applied to the world. If not, it becomes not significant, and probably you have to look into why it became not significant. So always keep this map. Keep this map in front of you when you are discussing with the statistician. So we go back to the home page. And if you tap at distill in a very diagrammatic way, starting from a challenging healthcare situation, you ask a question, a conceptual framework, then you make a hypothesis and distill objectives. So again, for a post, this is more like for a postgraduate point of view, understanding the design, how objectives are created in a very pictorial way, and PICOT. So I think this is quite familiar. In a population, you ask a question, if it's an observation study, you look at incidence, prevalence, causes, risk factors, prognosis, cause or perceptions, and intervention, of course, you have a case and a control group. So with using this as a simple map, people get sensitized to the research methodology.
Dr. Ramesh, your screen is not moved. Yeah.
Yeah, I just kept it at this. Now,
yeah, sure.
Now is where I call the magic of the app comes up, is when you are going, a lot of questions I heard in the previous talk, in a descriptive study, what to do, in a correlation study, what to do. So you tap on domain. So if you tap on domain, the possible 9 domains of research open up. So here is where the researcher has to decide, okay, which domain does my research belong to? Again, madam, just for the sake of interacting, Madam Dr. Hindu, if you can
yes, sir.
Which domain, let's take some hypothetical research you're doing, okay? I want you to create in your mind some study you're planning to take up. So that study which is there in your mind now, to which domain you think it belongs?
Risk measurement.
Okay, so you tap on risk measurement. And the screen over here also can go on.
Repeat, madam, which domain you have chosen?
Risk
measurement. Madam wants to look at risk measurement. Good.
Risk measurement, okay.
Okay, done. Okay, so this page opens up, no, madam?
Yes, sir.
Yes, so in your thing, this page opens up. So what is given here is, why do we want to measure risk? Why do we want to quantify risk? Is because we want to, in the longer run, we want to look at causation. If one risk is repeatedly associated with the development of a disease, then we go into probably this is the cause for it. All right. So that thing becomes clear. Somebody was asking a question, correlation, association. So here on the side, there's a nice diagram which tells there are 2 groups, one with risk factor, one without risk factor. You can enlarge it on the screen. And in each of the group, you're looking at whether the disease is present or absent. And it also tells you define group 1, define group 2. And then below you have to define what are you measuring in each of them. Either are you measuring a disease being present or not, or are you going to classify each of these cases as per a degree, like a category, mild, moderate, severe. So using this diagram, the researcher gets to know, okay, fine, look, does it look like my data when it comes out? I'm having 2 groups, and each group I'm going to see whether a disease is present or not. Ah, good, correct. I think it looks like this. If it looks like this, madam, then next thing that you will do is look at the question. Are neonates with family history of hearing impairment more likely to develop hearing impairment in compared to those without? Oh yeah, it looks like mine. Good. Then you go to the last line and then you fill in the blank to estimate the risk of having what? Let me, for you an example, madam, you took elderly with dementia, no? So what do you put here, madam, to estimate the risk of having?
Depression.
Depression in?
Depression, risk of having dementia in those with depression.
To estimate the risk of having, yes, in those with depression in comparison to?
Those without dementia.
Without depression, I know. I think
without dementia.
Yeah, elderly, I think depression leads on to dementia. That's what at least my little knowledge of psychiatry. So yeah, look, no, and if you see, does your data pattern fit into what you are, planning to do?
Yes.
So 1/2 will be what, madam? That 1/2, what will you label as?
1/2 will be those with dementia. The other will be those without dementia.
And you're going to see in them how many are depressed, how many are not depressed.
Excuse me, just a moment. Dr. Ashok, do you confirm that all delegates have downloaded this software?
I presume, sir. I mean, we'll have to.
You just give a message to them.
Yeah. We could. I mean, as you speak, sir, since as chairperson, as you have already announced,
okay.
Request all delegates, at least some of you who have downloaded that, please send in your comments saying you have downloaded, so we can see the chat and we will feel reassured that you are all watching it. Okay, please do that.
Or else it will be a boring one for them.
Yeah. Thank you, sir. Thank you. Incidentally, as I'm speaking now, Dr. Ramesh, one more thing is on this app, that page, for example, the risk measurement page that came. Okay, then to say that, you just slide to the left to get the other pages coming.
Yeah. I'm coming there, sir.
Yeah. Sure.
I'm coming to that, sir. So, madam, now you want to take people with dementia, without dementia, and you want to see in them how many have depression, how many don't have depression.
Yeah.
Or you can even do it the other way. Take people with depression, people without depression, follow them over a period of time and see how many have dementia, how many don't develop dementia.
Yes,
sir. So if you look at it, this could be even designed like a case control, or it could be designed like a cohort study. Yeah. So again, this diagram is very critical. Using this diagram, naturally you get to know how to design the study without having to rack your brain or using any mathematical or mental gymnastics. In a very simple way, you get to know how to design a study. Now, the second question that comes is, in this situation, how to calculate sample size? And before that, madam, on the top, have you seen elderly with dementia comes up?
Yeah.
Yeah, this is again to keep us in perspective that stay focused. We are working on elderly with dementia, and that is the mission. Now, madam, if you swipe the page from what I would say right to left, what comes up? This
data required
to calculate sample size. Does that come, madam?
Yes, sir.
Yeah.
Yes.
Data required. And if you can just read out, madam, what is there?
Proportion in control group, proportion in case group, power, alpha error, one or two-sided hypothesis.
Yes. So the
Dr. Ramesh, the chairperson was requested.
Data required to calculate sample size. There is a domain next back. This is not coming in app.
No, sir. You have to swipe the page, sir. You have to
just the page. You just hold the page and swipe it to the left, sir.
I will demonstrate here, sir. Here you are. You should.
Yeah. Okay.
Now you got it, sir.
Then this domain.
You go back to domain, sir. I'll just show it here. Go back to domain. Select risk measurement.
Yes, sir.
The page is there. Then you swipe the page from left.
Yes. Okay.
You got it.
Yes, sir.
Okay. This is magic rubbing of the magic lamp. Really active. So data required to calculate. So people were asking the previous thing, what is the thing required? So very simple. Control group, how much do you expect the proportion? Case group, how much do you expect the proportion? Here looking at risk measurement. So in people with dementia, how much do you expect the depression to be? In people with case group, how much do you expect the depression to be? Power alpha error we have already seen in the diagram that they have to decide either 5 or 20. With power 80, 100 minus 20, 80 or more. And one or two-sided hypothesis, I always give this mantra, tell two-sided, two-sided, two-sided. Except in kind of, ecological or some kind of studies where it can only take one direction. Like people, as we keep aging, we have chances of dying is higher. We cannot be living more. So that's like, one side, which is very rare, a few situations we have. So with this, you go to the statistician and you can either use online calculators or EpiInfo as it was shared before. Again, swipe the page. Madam, what comes?
Descriptive statistics.
Yes.
Odds ratio or relative risk.
Relative risk reduction. And 95% confidence interval or odds ratio or relative risk reduction. And if you again swipe the page, it tells you what test to write. See, always these PGs are in a jittery thing. Now though they are doing COVID duties and all the more, jittery. Sir, tomorrow is submission. know what to do. I can't meet statistician, and now it's 9 o'clock in the night. I don't know what to write in the inferential. Here it is, boss. Just write this for now for submission to the university. The inferential statistics for my study for this objective is either chi-square assumptions are fulfilled, Fisher's exactive assumption not fulfilled. Right? The assumption, all that you can discuss with the statistician, which is not very important now because that will really come after the data is cooked really, and so to say. So this in one branch you totally get now. For that data pattern, or which we call ANDA, with that for that question, the entire thing is ready. Right? Now, madam, go back to the domain. May I request some other person just to, for example, to interact with me? Professor Nageshwar Rao, are you okay? Or Dr. Ramakrishnan?
Yes, sir.
Yes.
Right, sir. So, which domain you think? Let's take a hypothetical study, sir. Which domain you think your study belongs to?
Is there a correlation?
Okay, so just tap correlation, sir. Yeah. Now, if you enlarge, why correlation? Because again, correlation is more to do with, it's a facet of causation. If two things are related, then they're consistently correlated over a period of time, and you can repeat it. That means probably that is the cause for that particular event or disease, right? And you just enlarge the thing and see, sir. If you see in one individual, they are correlating two numbers. So there was a question again in the previous thing: how to distinguish between correlation and association? This is correlation because numbers. That is association, where you have to be between two groups and looking at categories. So just by seeing if your data pattern appears like this or that way, the researcher gets an idea that, oh, mine is a correlation situation, mine is the association situation. So don't have to use your brain too much at all. I always tell my participants, don't use your brain for racking numbers and remembering. Just like, like driving a car, you don't need to know how the engine works to drive a car. You just need to know where to put the ignition key, see where petrol is there, and then start the car and keep moving. So again, just by fitting your data and seeing all this, two numbers are going to correlate. Okay, I'm going to correlate.
Sir, what is it? 3.42 means in a number?
Just an example. So for example, let us say you want to compare depression score with the dementia score.
Okay.
So the 3.4, that thing is the depression score. 2 point something is the dementia score. In the below, there is an explanation of it. One individual, name of one level, name of other level.
Okay.
So if you go closely and see the diagram, it will tell you what these numbers mean. So you should be able to fit your mental construct into this ANDA. So if your mental ANDA and ANDA on the app don't match, you go back to domain. Again, you go back to domain and round and round, you keep on doing till your mental construct fits to that ANDA. Once the ANDA match happens, that's it. Everything is done. So we'll stick to correlation, sir. So if you stick to correlation, if you can read the last line, sir.
They estimate the strength of correlation between quantitative parameter and
another quantitative
parameter 2 in P value.
In which population? So what did you fill here, sir? If you are doing a correlation study, which number and which number you would like to correlate?
So now it is as per as the slide is concerned, it is bilirubin levels and hearing levels.
Yeah, that's true, sir. That is for hearing kind of questions.
Yeah.
Your
so in case, suppose in the previous study, what Dr. Indu was telling, you can talk about dementia and depression.
Yeah, it should be scores here, sir. It cannot. If it is depression present absent, dementia present absent, then which is the ANDA, sir, data pattern? The risk measurement one. If you get the score, then this is the one.
Yeah.
And again, now you swipe the page, sir, and if you can read out what is written there.
Sample correct correlation coefficient, population correlation coefficient, power, alpha error, 1 or 2 sided.
Yes, that's all. Now with this, if you find this will be there in previous literature. That is, what is the population? What is the correlation coefficient between dementia score and depression score? Let us say it is anything above 0.5 is taken as good correlation. Let us say it is showing as 0.6, but you think from your thing, no, I feel it could be up to 0.8. So you enter 0.8, 0.6, power is 80, alpha error 5, and put 2 cells in the calculator, and like that, Patak, your formula is ready. And you just swipe the page, sir, and if you can go to the next.
So it's again descriptive statistics, correlation coefficient, 95% confidence intervals of correlation coefficient.
Yes, again swipe, sir.
So inferential statistics, Pearson's correlation, if data normally distributed, Pearson correlation if data is skewed.
That's all we need to know, because, sir, now with software, we don't need to use any formula. Gone are the days of formula. With software, either a licensed software or these PGs have some kind of software they have, all kind of latest software they seem to have on their laptops. Or online, there are phenomenal, beautiful online softwares available which are free to use, where we can just enter the numbers and you can do this test and just p-values and what else is there, the graphs, plots, everything come up. What is very important is the integrity of the data that goes in. As long as the integrity of the data that goes in is good, rest all just falls in place and it comes. And what you will get is, you will get this, you will get the correlation coefficient, and only you need to know what is good and what is bad correlation. 0.5 correlation coefficient is beginning of good correlation. The perfect one is 1. Now, if I can just request you, sir.
Yeah.
How much of what correlation coefficient you will take as acceptable? If 0.5 is the beginning and 1 is best, what will decide how much correlation coefficient you will accept? Dementia and depression will stick to.
I will say it's around 0.6.
Yeah. So there is no questioning of that, because you are the expert. You feel I would 0.6 is a good correlation and I want that. So again, the statistician may ask you the same question. What do you expect the good clinically important correlation coefficient to be? That 0.6 you have to tell, and that is the answer.
Okay.
So we go back to again domains. So that is this. So with this thing, without much of a knowledge of statistics, without much knowledge of mathematics, you only have to be a good clinician with some idea of the research methodology. You can get at the rest of the things just by going round and round and round this 9 domains. So what I would like to do at this point is, because talking too much details of each of those things are not required, because I will just touch upon probably descriptive. I can ask, a lot of questions came in the previous talk about descriptive study. So if you can, one of you can tap on the descriptive study. Indu madam, I'll again correspond with you.
Yeah, Dr. Ramesh. Dr. Ramesh, yeah, before Dr. Indu answers, one of the questions that come up in chat box, I think somebody joined late. They want to know what is the name of the software. So if you can just once quickly tell them about it.
It is called Research Genie. Research as in research, Genie as in magic genie. So Research Genie.
Yeah, that's G-E-N-E.
Yeah, G-E-N-I-E. Madam, Indu madam, so if you see, your small groups have come up, right?
Yeah.
Yeah, so if you see again, if you go close to the data pattern and see, very simple. Circle constitute the population, and in each population, either present, absent you are going to do, or you are going to measure them as a category as mild, moderate, severe. Right? And you have to fill in the blanks, madam, to estimate the proportion of depression patient, estimate the proportion of dementia patients in the.
Maybe we can go for a different question, sir. Anxiety disorders in healthcare workers during COVID-19.
Correct. Yeah, could be that. Yes, madam. To estimate the proportion of anxiety disorders in healthcare workers in this scenario. Now, if you swipe the page, madam, can you read, ma'am, what's written there?
Data required to calculate sample size. Population proportion, sample proportion, power, alpha error, 1 or 2-sided hypothesis.
Yeah, that is all. So, in the population, this is what you think. But I feel that, say 50% of health workers are having anxiety as per maybe some recent report. But I think, no, it's around 80%, I feel. So, your sample proportion will be 80. Power alpha, you know what is it. And if you again swipe the page, ma'am.
Descriptive statistics, ratio of proportion. Yes. 95% confidence interval of ratio of proportion.
This is what we need to write. And finally,
Inferential statistics is a test of proportion.
So this is what they have to write. And of course, depending on the software you have, I will use the software to do the Z test of proportion. P less than 0.05 will be taken as statistically significant. Done with the story close.
Sir, is there any formula for the population proportion, sample proportion and all that is there any formula for that?
Yes, sir. There is formula. Again, what you need to do, sir, is now if you go to the web, there are 101 websites which give the information. So suppose you take description, you go to the web and look for sample size calculators, and there you have to just put, that is you are looking at estimating the ratio of proportion in the population. The sample size calculation software will open up, and there you should see whether these 5 parameters are there.
Okay.
If these 5 parameters are there in the sample size calculation software, there will be one somewhere in that software, either it will immediately show the formula on the top, or there will be one place where you tick and it will show that how this calculation is being done. It is done there in all the online free softwares. So you can take a screenshot of that, trim it and paste it on your work. So this is, though you're using a calculator, you say that you use this formula to, sometimes the national board asks how was sample size calculation done. So I tell my PGs, please copy this, put and send it. This is how the sample size calculation was done. Because we don't need to know how the working of the formula. That is because software works on that. In this day and age, we don't need to know the formula at all, except maybe for statisticians and community health postgraduates. Rest of us, we just need to put that formula on the document and send it. Does that answer, sir, your question? So at this point I will stop, because I think taking more questions and explaining how to use this application to get their solutions will be more useful. One more question was there, how to differentiate between correlation and association. Very simple. Go to the app. Correlation, there should be 2 numbers to correlate. Or association, risk measurement, there's association of one with the other. So which data pattern? Is it the ANDA with the center cut where you're seeing the association between 2 groups, or is it correlation where you're correlating between 2 numbers? Because for statistical terms, correlation is between 2 numbers. What we loosely talk as I want to correlate with dementia with depression is not accurate statistically, though we talk in our clinical sense. For statistics, it's only 2 numbers can be correlated, whereas 2 factors only can be associated, that is risk measurement. That is the ANDA with the split in the center with depression present or not, or dementia present or not.
So I request delegates to pose questions.
Yes, now is the time. If some of you are writing up a thesis, synopsis.
And it is a good software, I think, which you can very well use it. You can combine this with our whatever software available over the net. I think it is a good idea what Dr. Ganesh has done, Ramesh has done. So we need more participation, or else it's very difficult for the speaker also to get enthusiasm. Sir, maybe one of my suggestion is that it is a good initiative, Dr. Ramesh sir, and the subsequent following years we plan to have workshops for postgraduates. Maybe that may give them more freedom and to interact with you personally, and they can learn more. That's what I feel. That is the idea of Dr. Ashok. He has been telling that.
Oh, yes, sir. That I think postgraduate will take some time, because right now they are just in the first year. Some of them maybe not even got a grasp of the things. So that takes some time for them suddenly like this to ask them to even get them to identify a domain takes time, because in my workshops, sometime if I start at 9 o'clock in the morning, sometime around 3-4 o'clock they start getting embedded in this. Start thinking in these lines, 9 things. But I can request the faculty here to ask me, sir, because you can teach these students. So you can ask me queries so that we can sort it out there. If queries come from the students, we can answer.
With the permission of the chair, I mean, I'll just put up a question for you, Dr. Ramesh, because common dissertations that a lot of students do. Okay, it's prevalence of depression in caregivers of patients.
Yes, sir. This is the topic they choose.
Yes, sir. Now, this if you takes, I mean, again, sir, if with your permission, if I can ask you to interact with me, if you were to look at the 9 domains, where do you think it fits, sir?
Yeah, it's in the app. Let me see. Just okay, domain. Prevalence, incidence of prevalence.
Okay, now tap that, sir.
Okay.
Now, if you read, sir, what is the incidence, new case or prevalence, existing cases of hearing impairment in the Indian population of children?
So,
see, are you looking at a population? Then you would ask yourself, sir, are you looking at a population study where you'll go to a district and look?
Yeah, the common way they do study is, patients are admitted in the ward.
Hospital, yes.
Caregivers are present. They will look at, some amount of distress or something. I'm just giving a common, examined a lot of cases. This is one of the common kind of studies that they would study. That there are attendees, they would like to know, how many of them are. It could be burden, a measurement of burden in them, a measurement of stress in them, or measurement of prevalence of depression itself, so on.
No, sir, this looks like a population-based study. So, no, this is not fitting into my question. So, go back to domain, sir.
Go back to domain, yeah.
Now you see, once again, we have to see the boxes, sir. Where is now it doesn't look like a population study. So then what?
Description.
Description.
Tap on that, sir.
Okay. Yeah. So what proportion? Yeah.
Does it appear like this, sir?
Yes, sir. This is okay. To estimate the proportion of depression in the caregivers of schizophrenia.
Yeah.
Yes. Now it looks like this. Fantastic. Go and look at the data pattern and see. Okay, there is this circle consists of all the caregivers of people with depression, in which you are going to see something present or absent.
Yes.
Correct. This is my area. So go swipe and see what is the required for sample size calculation. I want to see in my sample, what do I expect the proportion? What do literature tells the population proportion? Alpha, and how much would you like to fix the power?
Yeah, we keep it at.
Yeah, so 80. So
80% standard.
And 5% alpha or 5. 1 or 2 sided, always 2 sided. And then put it into the calculator and get the thing. And of course, take for this loss to follow up and things like that. So at the page, I will the proportion of people. So what I will look is the proportion of caregivers who are developing particular burnout, for example.
Dr. Ramesh,
what is the 94% confidence?
Dr. Ramesh, yeah.
The population will be outpatients attending the clinic.
Yes,
sir. Population.
That's the population. Yes, sir.
Sample will be, I will be taking 200 samples.
Yes, done. But again, you have to do the sample size calculation, sir. Then it will tell you how much you have to select from the OPD.
Yes, sir. Yes, sir. Okay, good.
And then you'll write this is the descriptive statistics, and finally I'll do the Z-test of proportion to look at the statistical significance. Done.
Okay.
Okay.
Anyone else wants to interact for the sake of PGs?
Sir, can I add something to the correlation association doubt that was raised by the PGs?
Yes, ma'am.
So you have explained how to decide whether it is correlation or association. I tried to clarify the concept for them.
Yes, ma'am.
Correlation refers to how one variable varies with another.
Yes, ma'am.
So how height varies as weight varies as height varies.
Exactly.
That is correlation.
Yes.
So how does the score of anxiety correlate? How the scores of anxiety correlate with scores of perceived stress would be an example for correlation.
Yes, ma'am.
When you speak of association, you are measuring the risk, whether one factor is a risk factor for another. So how much one variable is associated with other. So whether alcohol dependence is a risk factor for attempted suicide. So there will be an association. You are measuring the risk. That is the difference in concept. If you are measuring how one variable changes as another, it will be correlation that you want to measure. If you want to see whether one variable is associated with increased risk for a particular outcome, you are looking at association.
Exactly.
Just to continue with that example, Dr. Indu. So association in your example about stress and anxiety would be you're looking for how many patients with anxiety compared to normal people would be showing association with, say, a measure of stress. So that would be, so comparing stress in the two groups, that would be, you're looking at association. But if you're looking at stress scores and anxiety scores and you're relating them to each other, that's correlation.
Yeah, you're taking anxiety as anxiety disorder present absent, and you're looking at stress present absent. You can assess whether there is an association when the stress is there is increased stress. Is there an association with anxiety disorders? That way, the same question you can look at it in.
But can you have multiple variables? Because of can you have multiple variables?
So you can look at correlation between different scores, different variables. You have scores. When you are measuring association, you have to look at different variables. That is a must because confounding has to be addressed.
Yeah.
That is another topic.
So another question has come up. To assess the mental capacity in persons with mental illness admitted in a tertiary care center, how to go with this aim?
So let's go back to the domain, sir. So you're looking at mental capacity
in persons with mental illness admitted in a tertiary care center.
Done. Now you look at this, sir. Which box it looks like?
Capacity means again it is a new test, isn't it?
No, don't bother, sir. You just choose one box which you feel fits into your question, which describes your question, so to say. So you're looking at mental capacity in people with depression, no, sir?
Yes, sir. No. In mentally ill people, how to assess?
Sorry, mental capacity in mentally ill people who are coming to your OPD. All right. Which box it looks like, sir?
It is a validation test.
It's like looking at what it's the existence of some phenomena, the prevalence of some phenomena in a group. So the prevalence, incidence prevalence, would that meet that?
Again, then we don't have to do anything, sir. Just tap on that and see.
Okay, the point here you're making, Dr. Ramesh, is whichever you think fits, you just go there and see if you have all the data to continue like that. I mean, it is just so. Yeah, I got it.
Yes, sir. Yes, sir. That is again description. That is incident and prevalence. It comes.
But again, sir, I request you to just go to that domain, click and see whether your mental construct is matching to what is put there. Here, if you see incidence of prevalence in the Indian population, look at population-based study, but you are looking at a ward-based study. So there, your mental construct and what is there is not matching.
Yes.
So when you are not matching, what do you do, sir? Go back to domain. Now you tell me, sir, which else can you choose? Which other box looks like that?
Maybe therapy.
Go to therapy. In severely hearing impaired children, communication ability gained using analog with 2 interventions you are using. Does it appear like that?
Yes, sir. We want to assess the mental capacity.
Yeah, but you are not doing 2 treatments.
Yeah, we are not doing 2.
Not again, go back to domain, sir. So you have checked incidence prevalence, therapy not matching. Which other box you can check?
Basically, we are assessing the risk measurement.
Go to that, sir. 2 groups. Are you having 2 groups? One with risk, one without risk?
No.
No. Go back to domain, sir.
Then go to description maybe.
Does it look like description, sir?
Yeah.
Let us check.
It is referring to what proportion of something exists in a particular population seen in a hospital. So what proportion have mental capacity in patients coming to that hospital? Any patients. So it may match.
Again, you can probably go near the data pattern and see. It doesn't. If you look at it, that you can either define as present absent, or you can also define as various categories.
Because the last line there says the estimate proportion of something in the dash. So proportion of mental capacity in mentally ill.
Yes.
So
That's
that matches. Then we go to the next. We swipe and go to the next point.
Yes. So, sir, do you think now this matches your mental construct of what you wanted to do and this picture and the question?
See, we are not assessing the proportion. We are not assessing proportion. We are assessing the capacity. Means there is a scale. Maybe 50% they have to achieve. That's what empirically.
You're right. Okay, sir. That means yes, got it. What else is there, sir? You see here. What else is there? You see the lab range. We will not go near it because lab. We might think is a laboratory thing. Just stick lab range.
Yeah, correct.
You read, sir.
Estimate the mental capacity using some scale.
Yes. Now you see. Does this match your construct?
Exactly.
Yes, to estimate the range of mental capacity measured using some scale in
our patient or the 100 patients.
Yes. Now you swipe, sir. Go to the next. You see data required for sample size calculation.
So you need a standard deviation, sample mean, population mean, alpha power.
Yeah. Descriptive statistics, inferential statistics.
Sir, one doubt.
Done. Only thing, sir, the chairperson. I am at exactly 7 o'clock. I think. Now take a call.
The permission of it is up to the organizing committee to decide. The people are.
Yeah, Dr. Ramesh, if you can just bear with us for a few minutes.
I am okay, sir. I am passionate about this work. I can be here till 9 o'clock.
But as long as the candidates are not leaving, you can continue any number of hours.
Thank you. Dr. Indu had a question. Yeah, Dr. Indu had a question.
Yes, sir. Would the new test be a better option for the question that Ramakrishnan sir put?
Yes, sir, madam.
Because what he wants would require a sensitivity, specificity, all that.
But
For a
it's only
diagnostic.
referring to a new test. It's like we are developing a new test that will become necessary. But the previous one was very good actually, because lab is the scale. The scale that is used for measuring the capacity, and then the estimating that capacity using this particular test in some population. So the for that question, the lab range idea seemed correct. But the new test, what you are saying, Dr. Indu, I think it fits if you are having a new test developed or developing, and you want to see how it is valid and all that, then the new test thing will.
So wasn't that what sir was referring to when he said he wanted to find out how the mental capacity could be measured in a particular population using some scale? So if that.
Madam, just to interrupt, just to clarify, because I think that sir's doubt got cleared, but I will clarify your doubt. You go to the test, ma'am. You choose the test.
Yes.
Can you read, ma'am? The question is to compare the sensitivity specificity of, for example, diagnosing mental capacity, okay, among mentally ill patient using a new test in comparison to the reference test. That is not what he is doing, no, ma'am.
Okay, there's no reference test or gold standard.
Yes, yes. He is just describing. He is just finding the mean level.
Okay.
He will tell, oh, this is not my area. You'll keep on. So what you do, round and round and round you go, and when your mental construct matches with the diagram and the picture, you are there. So you don't need any mathematics. No, sitting in your OPD, OT, anesthesia, wherever you can figure out which is the design for your work and how to write the statistics.
Has Dr. Jyoti Bosch got clearance? Cleared your doubt?
Yeah, he's. Yeah. Yeah. So respected sir, Dr. Ramakrishnan, what Jyoti Bosch is doing is he is copying the from the question answer box and putting it here. So that's Dr. Nilima. Dr. Nilima has asked that question.
Okay, Nilima, is she satisfied with the answer?
Only thing is, on this forum, we don't get a feedback.
No, ask them in the other forum, ask the question. I think they will be listening. Dr. Nilima, give your answer. If she has happy, the whole program is a success. That's what I would say. That is a yardstick for us. People have understood the app. Dr. Nilima is the acid test. Sorry, just for a lighter sense only I'm telling. No response?
Question is put, sir.
No. What sir is wanting is to know if she got the answer because sir read out for it. Is she satisfied with finding out how to go vote in the app? If,
I think we can say understand that she has understood because
Yes, sir.
so we'll hope in his best interest. Shall we close the session, sir?
Yeah, one more question, sir. Suppose if you are doing a new study, suppose now we talk about COVID corona patients, and to study the depression levels or prevalence of depression in patient with corona admitted in the ward. So we are not having any statistics.
You go, sir.
We want to find out.
Box, sir.
So what, sir?
Go to the domain. That domain you select in the app.
I'm talking about sample size.
For that only, sir. Now you are thinking in patients with corona, how many have depression, right?
Yes.
So in the which box it belongs to?
So prevalence.
Again, sir, prevalence incidence of population, that is in the district, in the ward, in the municipal, community, like that.
But can we
in the given population
of 1,000 people in attending the
suppose the target population of the hospital who are admitted in the hospital.
Right, sir. So it is 9 boxes. If it is not incidence of prevalence, which other box will be yours?
Only if you say that depression and the COVID, then it will go to lab range only.
Are you going to measure this depression scale using a scale, sir? Depression? Or
yes.
Okay, then you tick on lab range.
That last line will help. That last line will help to estimate the present depression or measured using some rating scale in this population, in this group. So
estimate the range of depression. Here will be to estimate the range of depression score. If you are looking at depression present or not, then it will be the description box to estimate the proportion of depression in COVID patients. That's what that data box data pattern will tell you. Each patient, are you measuring depression present, absent? Then it is this one. If you are measuring depression score, then it is the lab range. So there you will be using a score.
Yeah. This is the description is the domain.
Yeah. So your domain is description, sir. How do you calculate sample size? Just to swipe the page.
Population proportion.
Yeah. That is how much do you in the previous studies or your perception is what? Sample proportion?
No.
Do you expect it?
This is a totally new study. Previous study.
Some idea you will have, no, sir, with your clinical work.
Okay, so we should have some. So if it's totally new, then we want to come up with a new study.
Yes, if it's totally new, still you have to make a clinical estimate. This is what statistician will ask.
So suppose
if you tell them it's new, they will sometimes get little depressed.
So example is, if I am trying to look at depression in a patient with corona, COVID, I can try to look at so depression in a patient with previous illness. Suppose in the previous epidemic, that I can take it as a...
Excellent, sir. Excellent. Any other epidemic, generally what is the depression you see, and then you tell how much more or less you are expecting, and that's it. Alpha.
So previously we had swine flu. During that time, what were the studies showing that? Okay, that's
exactly. Exactly. That is it. And then you fill in this thing and get the sample. Done.
Okay.
When in lab range only it will come, isn't it?
Sir?
Again, it will come into lab range only.
He's looking at the description, sir. Lab range is what is the range of depression among depression patients, like that it will go.
Okay, sir.
We are seeing a depression score, how it varies.
Okay.
He's just looking at depression present or absent.
Okay, sir.
So, sir, we have questions, sir, now. Can we go through the questions?
Yes, sir. I think
Use MACCAT T for assessment of mental capacity, Dr. Nilima.
And she has told that, yes, sir, I am satisfied.
I am satisfied. Thank you so much.
That's what we were expecting. Thank you, Dr. Nilima. Big applause to Dr. Ramesh. So we have to you have more small work groups spread over years, so that the participation will also be more, and they should bring some studies and then they will understand. Each one should bring a topic, how to put in. Like that, if they do, they can get more interest, and they can also join hands with other co-PGs and all, and they'll have some motivation and encouragement. See, that is what our aim of research capacity building is all about. And I think I'm hoping that this research building capacity the subsequent year also will be doing the same enthusiasm to bring up more equipment, that is equipment of new psychiatrists for our national World Mental Health Day theme, enhancing investment. These are investments. And enhancing access. These are the two aims. And I think we have satisfied this. Over to Dr. Rangeshwara to give the conclusion.
Concluding. Okay, and my wish as well as my want is, if you all feel this app is of useful use and you want to use it and you want to use this method to teach, there's no copyright to this entire thing. Though, because we have right copyright, please use it and make the education of research methodology and statistics simple, so that we can inspire the next generation to create knowledge for this country, because we have become consumers of knowledge. It's time that we create knowledge, have our own books, our own guidelines, which is very appropriate for our population. I think psychiatry is quite well up in that sense. But if you see, we surgical specialties to a great extent are lagging behind in creation of knowledge. Then when we became a knowledge, this pandemic has shown that if we are a knowledge power, we can survive. And you can see India surging back economically so well, because every individual in India is so intelligent. He knows how to make money. We don't have to worry at all. Like the RBI is predicting that at the end of January we are done with Corona and its economic effects.
Okay, sir. That's we are all bound by Western knowledge, Western statistics. There is no Indian statistics.
Yes,
so we have to produce more Indian statistics. So then only we will be looked up by other people. Or else we are a copy paste like that. And honestly, India and China are copy pasted. Right.
But sir, this pandemic, India, China are stronger than the Western nations. America is sinking, whereas we are just surging forth in economically.
Because of the immunity and other aspect, there is other God.
True,
sir. Thank you.
I would like to thank Dr. Ramesh for making it so simple, the difficult task, making it so simple. And so I think this has been very useful to all the delegates who had been participating, and especially for the freshers, making it so simple for them. I think the whatever stigma is associated with the statistics that might have been minted over. So I hope we will have future workshops, as Dr. Ramakrishnan said, so to garner more into this research, and at the same time having to get acquainted with the skills, so how to apply these things, so how to go ahead with the research and all those things. So I thank all the delegates, and so tomorrow again we'll be joining around 10 o'clock. So make sure that everybody gets back tomorrow at 10 o'clock, and we'll have another academic feast, so to be continued. So thank you, one and all.
With the permission of the chairperson, Dr. Nageshwara, with your permission, I just want to make this announcement.
Yeah.
Dr. Vijay's talk on which measurement tools to use, which was supposed to be held this evening, has been postponed to tomorrow morning. Dr. Ramesh's talk was held in his place. So tomorrow morning, all delegates can, the first talk would be by Dr. Vijay on the which tool to use for your study. And the second, the panel discussion will go on. I thought we'll just start with that. Yeah, thank you.
Thank you.
One and all, especially.
So I hand over to Indu.
Well done.
Thank you, sir. Thank you for a big thanks to the chairpersons, Dr. Nageshwar Rao sir and Dr. K. Ramakrishnan. The utmost thanks to Dr. A. Ramesh for such an interesting session, and also for giving us a sort of Byju's app for research methodology. Thank you, sir. Thank you for an excellent session. Thank you.
Thank you.
I hope this
Thank you all of you.
inspires all the PDs to take up new research topics. Thank you, sir. And thank you one and all for the active participation. Looking ahead for an active session tomorrow also. Let's join tomorrow morning at 10 o'clock for the further two sessions. Thank you.
I request Prashant and Srikar to stop the streaming.